Welcome all to the Programming for Tomorrow Health and Wellbeing by Design webinar. Introduction of our presenter today is Vernon Woodworth. He's our Life Safety and Code Consultant Service Leader for Fitzmyer and Tachi. I'm Cheryl Butler, the Business Development Coordinator. Just a few comments before we start. All will be in listen-only mode. If you wish to ask a question, please type in the side chat bar. Presentation will be 15 to 20 minutes long with questions at the end. I will present the questions to Vernon to answer. This also will be recorded and then forwarded to all attendees. Enjoy the webinar.
Thanks, Cheryl. This is Vernon. Thanks everyone for joining me today. The idea is that the process of programming, which establishes goals and performance for a new building or space, can encompass aspects of a building's future function that encompass well-being and health, as well as spatial requirements and productivity, which are the usual focuses of a program. Life safety, sustainability, health, and well-being are more or less considered code matters and taken for granted in the programming stage, but we're in an age where an increased understanding of the importance of health as an environmental factor, as a part of our relationship to the world around us, has become quite prominent. And I think that COVID-19, if there is a relationship to the issue of the built environment and of sustainability, it probably has to do with an increased understanding of our relationship to the spaces that we inhabit and the way which we relate to others. So this presentation will focus on recent research in the physiological impact of natural patterns and living organisms, which is described in general as biophilia, along with some discussion of findings from the field of neuroscience, which provide insight into the acute sensitivity of our central nervous systems to our environments. We can go to the next slide, which describes that there's probably something we all know all too well, that the rapid warming of the planet, along with pervasive degradation of our ecosystems, is also drawing into our awareness the importance of sustaining natural systems. So I want to start by talking a little bit about systems, because I think we need to apply systems thinking more carefully to our programming and design process as well. Systems tend to be complex interactions between various elements that have a dynamic potential to both maintain some sort of balance or homeostasis, but also to undergo growth and change. And the ability of a system to withstand adversity, such as disease or drought or economic decline, is called resilience. We've heard this term a lot, and now it's applied frequently to both the built environment in terms of its ability to withstand climate change, and to social groups in terms of response to the COVID-19 pandemic or even the economic consequences of recession. So resilience is a common dynamic of a healthy system. An individual who is resilient has a level of health and well-being that allows them to bounce back from physical or emotional injury. A resilient ecosystem maintains diversity and efficient energy transfer through a broad range of climatic conditions such as drought or temperature change. And that's really what an ecosystem does. It transfers energy. First, it captures it from sunlight and transfers this to energy that is progressively transferred between organisms and species to a higher state of diversity and resilience. So you can talk about the evolution of an ecosystem in terms of its level of resilience. Critical factor in resilience is the ability to regulate or contain external impacts on internal states. So, for instance, temperature extremes can be modulated by shade and massing, evaporation and condensation, and absorption and reflectivity, all of which are adaptations of natural systems, but which can also be maintained and employed by constructed environments. When conditions overwhelm a system's ability to maintain homeostasis, the result is dysregulation. Dysregulation means things are going bad, and a dysregulated system cannot maintain equilibrium, ultimately leading to collapse, or at least to a regression to an earlier state of regulation in order to start the process again. So I think the main point that all design professionals and developers and property owners should be aware of, and also government officials, is that we have all the tools we need to create a resilient building and human spaces for interaction. We know that biophilic environments promote mood regulation, healing, learning, productivity, and social interaction, also happiness. And what we mean is that environments that have views to nature, that have plants and illustrations of natural settings, that have patterns that reflect natural forms, and that use materials that are natural, such as wood. Just wood grain itself is a biophilic trigger that creates a response in our brains that can be measured, and the release of chemicals based on that receptor response creates a relaxation of the central nervous system. Daylight, we also know, is a key ingredient in cognitive functioning and promotes the healthy regulation of our circadian rhythms. Turns out that all living beings have genes that respond to the circadian rhythms of day and night, and also to the movement of the moon and its phases, and that a great deal of our neurochemical emissions and transmissions are related to these rhythms. Finally, our environment can promote exercise, sociability, self-esteem, and well-being through design choices and affordances. And affordance is a general term to describe the providing of an opportunity. So, for instance, a chair is an affordance to sit down. A gym is an affordance to work out, etc. And when we're thinking about human relationship to the environment, we are really thinking about what can be afforded as an opportunity for the users, the end users. We have a number of tools that can be used to monitor and measure the automatic reactions of our central nervous system to environmental stimuli, and these include eye tracking, galvanic skin conductance measurement, and emotional assessment software. These determine which stimuli promote regulation and which do not. I've been doing work recently with a colleague, Ann Sussman, who is also a teacher at the Boston Architectural College. And she has used eye tracking extensively to show what architectural forms draw our attention and hold our attention and what do not. And her findings confirm what others have known for several decades, that we are programmed for facial recognition, and we will automatically seek any form that resembles a face as a way to identify an individual, whether they're known or unknown, and also to assess their emotional state, whether they are friendly or hostile, and that this automatic reaction of our central nervous system through our eye movements occurs without any conscious control constantly, whether or not the stimuli are people or buildings or pictures or whatever. So you can take a simplistic conclusion that your building facade should resemble a face, which is not an unreasonable conclusion, but you can also go beyond that to understand that we are simply not going to respond visually, neurologically, and emotionally to compositions that do not draw the attention of our central nervous systems. And then, of course, if what we see suggests safety and happiness, we're going to respond as well on a parasympathetic level. So this process of biometric monitoring is a common technology used extensively in car design, advertising, web and software development, but very rarely in the design professions. And that's a head scratcher, because it's our decisions which are most ubiquitous in the world we live in. So by understanding that we have innate expectations for the world we inhabit, expectations that have developed and evolved over millions of years of evolution, and that our sense of safety and well-being depends upon meeting these expectations, we can improve the quality of our world and our lives. I think it's fair to say that a world of traffic intersections and commercial advertising probably does not meet the evolutionary needs of our central nervous system. So, with our understanding of the contribution of buildings to greenhouse gas emissions and the need to keep these emissions below 2 degrees Celsius for the benefit of the planet, it is imperative that we take into account the long-term impacts of all new construction. If we're making a program for a new building, we have to understand that it's going to exist in a world that could be greatly changed, and we can anticipate that and establish goals that take this into account. So programming can establish life cycle targets for new construction, energy consumption targets, contributions from alternative energy sources, stormwater management strategies, passive survivability tactics, urban heat island effect mitigation, and other sustainability goals. And together with a deeper understanding of human factors and the potential for developing environments that promote health and well-being, these strategies amount to a paradigm shift in our approach to design and construction. So that's what I mean by programming for tomorrow, is to essentially reframe our understanding of what a building is and how it interacts with its users and the world around it. If we can maximize the interaction of user systems, building systems, and natural systems, then we can reinforce the resilience of each. So in other words, if we build a building as a fortress to withstand a heat wave with provisions for the occupants and ignore the consequences of urban heat island effect with a black roof and a lack of external shading, we are only temporarily providing for a certain limited population. But if we understand that the building is part of a system that involves solar radiation absorption and the cooling effects of landscaping and other planting and the way in which any vegetative matter emits moisture and oxygen, and we work with that, then the people who have access to a natural environment in a space that is harmonious with local systems, natural systems, are going to be healthier, and the environment's going to be healthier as well. So because of anticipated changes to climatic conditions, the buildings we program, designed, and build today must be able to function effectively under potentially very different circumstances. Successful adaptation to the challenges of climate change requires close cooperation. The requirements of our central nervous systems for social interaction and cooperation include a supportive environment that promotes a sense of safety and well-being. And I just want to dwell on this for a moment. The point here is that gated communities, or that fortress with a weak supply of food and water and a well-tuned air conditioning system, will not create the social conditions necessary for long-term survival in a changing climate. What's required is an environment that promotes social interaction and cooperation, and that is something that requires a certain reaction of our central nervous system, and that reaction can be anticipated and promoted through design. So we know that by 2060, 80% of all the people on Earth will live in cities. I think we're closing in on 8 billion by then. And that current demographic trends point to the disappearance of the middle class over the same time frame, with the anticipated result that there will be a large population of wage earners and a wealthy elite. Any building in the programming, design, or construction phase today will be in use and form the basis for our urban life in 2060. And I think the COVID-19 pandemic has emphasized that relationship between resilience and equity. It may not have been obvious prior, and it may still be difficult to fully grasp, but the fact that certain populations have suffered unequally as a result of the pandemic, not just physically in terms of disease, but also financially and obviously emotionally, makes it clear that the need for cooperation and equality, equal opportunity, and sharing of resources is necessary to maintain the social fabric. The more inequity, the more likely there will be fraying of that social fabric. So the more society is fragmented and wealth unequally apportioned, the less resilient are our social and political systems. I'm not sure everybody who's listening to this has a familiarity with the programming process and may wonder why I'm talking about programming, although it's clearly not my professional role. But I have been teaching a course at the Boston Architectural College that includes programming for the last 15 years and have come to appreciate its potential. So on smaller projects, programming is typically done by the design professional, often in a somewhat cursory manner, and the results can be incidental. But it's important to recognize that without programming, there is no clear statement of goals and outcomes to guide the design process. So a program is of great importance to an owner, and they should be educated to know that, because it will safeguard their objectives and also establish their budgetary restraints. And maybe of less interest to the owner, but of importance to the design professional, is that this stage in the planning process is key to achieving broader social and environmental goals. Now, we're all familiar with the process in project development of the importance of the economic bottom line. The cost and the risk involved in building anything is always a major factor and is certainly part of the programming mandate. But there are other dimensions to project development that also have to be considered, and they also have impacts of a financial nature, if not directly for the owners, then at least for the jurisdiction in which the project is occurring. So for 20 years now, the American Institute of Architects has been promoting the triple bottom line of people, planet, and profit, and considering potential impacts in all three categories. And if this is done in the earliest stages of project development, we make possible a future that is more sustainable, more equitable, healthier, and happier. And that's why I think we should think of programming in terms of what's coming tomorrow. Happy to answer any questions.
Thank you, Vernon. Yes, we do have a couple here. What role do you see for building codes in establishing the goals of health and well-being that you describe?
It's an interesting question because it's wide open. I've seen developments in codes around resilience and in zoning codes around issues like water infiltration and conservation. Eventually, it's not unlikely that the findings of neuroscience and biophilia will have some kind of code dimension, if not focused entirely on health and well-being, then at least for the sake of minimum standards and also potentially sustainability. So a building that incorporates vegetation will reduce heat island effect and promote habitat development and diversity, and do a number of other things that can be seen as positive purely on an environmental level.
Thank you. One more. How can architectural practice adapt to the findings of neuroscience and human factors to achieve an environment that is healthy for all?
Another big one, the findings of neuroscience and their implications is still a very young field. However, there is important research being done by the Academy of Neuroscience for Architecture, which holds a semi-annual conference. This one will be online this fall. Ann Sussman and I are also on the board of a new organization called the Human Architecture and Planning Institute, which conducts eye tracking surveys and explores the impact of various environments on the central nervous system, but it's yet to be incorporated on a systematic basis, and I cannot predict how or when that's going to happen.
Okay, thank you. That's what I have for questions. Thank you all for attending.